Assalamu alaikum, I am Osamah and today I'm going to talk about semiconductors. First of all, what is it? What is a semiconductor? And what do we mean by a semiconductor? Simply, it is a substance and it is usually a solid element or compound that can conduct electricity under some conditions, and that makes it a good medium for the control of electrical currents. Now, how it works. Well, in a sample of metal containing many atoms that have many molecular orbitals, that they are so close in energy that instead of making bonding and anti-bonding orbitals for each pair of atomic orbitals, they make a band of bonding levels, which is called the valence band, and a band of anti-bonding levels, which is called the conduction band. Now the band gap can vary from nothing for the conductors between the valence band and the conduction band to small amount in the semiconductors, and that's what make semiconductors. And in the insulators, there's a large band gap between the valence and the conduction bands. Now, the band gap is a major factor determining the electrical conductivity of a solid. Here in the conductors, the band gap does not exist, or sometimes it does exist, but in very little amount, because the valence band and the conduction band overlap. So the electrons can move freely from the valence to the conduction band without any energy loss. Here in the semiconductors, the band gap, the relatively small amount of the band gap, prevents the electrons from moving from the valence band to the conduction band. But according to because of the small amount of the band gap, we can do something and make the electrons move from the valence band to conduction band by applying some heat or generally kinetic energy, and mostly heat. While the insulators, as you see, the valence band, the band gap is very large, and thus the electrons cannot be moving, even though when we apply some heat or give them kinetic energy, we cannot make them move. Now, when you want to make semiconductor by two elements, we need that the summation of the two valence electrons of the two elements to be 8 electrons, and we have this exercise. So let's see if these three combinations can agree or can move along with the rule. So now we have gallium. And gallium has 3 valence electrons, and selenium. Selenium has 6 valence electrons. So when we add them, they're equal to 9 electrons, while this 9 electrons and 9 electrons is greater than 8 electrons, so this cannot be a semiconductor. Here in vanadium and phosphorus, vanadium has 3 electrons, 3 valence electrons, and phosphorus has 5 valence electrons. When we add them, we get 8 electrons. So this can be semiconductor. Here in the cadmium and tellurium, cadmium, as we know, has 2 electrons, 2 valence electrons, and tellurium has 6 valence electrons. So when we add them, we get 8 electrons. So this also can be a semiconductor. Now we have doping. What is doping? Briefly, it is the process of adding substances to a pure semiconductor for the purpose of enhancing its its conductivity. And now we have doping. What is doping? Doping is the process of adding substances to a pure semiconductor for the purpose of modulating its conductivity, or for enhancing its conductivity. Now, as you see here, we have silicon atoms bonded to each other, and every atom, as you see, is surrounded by 8 electrons. This is the normal semiconductor, or the pure semiconductor. We have two types of doping. We have N-type and P-type. First, the N-type. The N-type is what makes it different than pure semiconductor, is that the pure semiconductor is injected or doped by an atom of phosphorus, or an atom that has more than or not more than 5 valence electrons. Like for phosphorus, we have 5 valence electrons. With 4 atoms of silicon atoms bonded to the phosphorus, we have 4 and 5, we have 9 electrons. So 9 is more than 8. So this semiconductor, this type, is partially negative. Now, the other type is the P-type. It is the same as the pure semiconductor, but it is injected or doped with an element or an atom that has 3 valence electrons. So we have iridium. It is from group 3 in the periodic table. So we have 3 valence electrons, and from each one of the 4 silicon atoms, we have 4 plus 3, we have 7. So we have -1 negative charge. So this one is partially positive. Now we have some applications for the semiconductors, and especially for the dopant. We have the electronic components like transistors, like processors, and diodes, and also in the solar panels. They are useful, and there are many more applications. We have here the example of solar panel. We have this cross section or picture, whatever. We have here the semiconductor, the N-type. Because of the phosphorus, it has 5 valence electrons plus the 4. We have 9. So you have an additional negative charge, which is the electron. And here we have the gallium, which has 3 valence electrons, and with 4 other electrons, we have 7 electrons. It has here has a positive gap right there. So this is partially negative, and this is partially positive. So when the sunlight hits the solar cell, it gives the electrons, the additional or the exceeded electrons, kinetic energy to move from this place to this place, because we have the positive charge here. The negative goes to the positive, and so on. This is how solar panel work, and this is how electricity work. It works by the movement of electrons.